Hello and welcome to part 3 of the GWN7800 switches video guide series. In this video, we'll cover link aggregation and demonstrate how to configure it. GWN7800 switches support the link aggregation feature that allows us to bundle multiple Ethernet links together so they can act as a single logical link. This provides an easy way to improve connection capacity between two switches or between a switch and a server or a router. For example, when 4 gigabit ports are bundled as one logical link, the link will provide 4 gigabits per second bandwidth. So the main purpose of using and configuring link aggregation is to increase and multiply bandwidth between two devices. Another important reason for using link aggregation is balancing traffic load among the physical connections in the logical link to improve network performance. In case one of the links goes down, the remaining links between the two switches will still be running, which increases availability of the connection. So this could be useful when you need to have redundant links between two devices. There are a few things to keep in mind when configuring link aggregation on the GWN7800 switches. The GWN switches support up to 8 link aggregation groups depending on the switch model, and you can have up to 8 ports in a link aggregation group. All ports in a link aggregation group must be of the same media type, including speed and duplex. This applies to both ends of the logical link. For example, if you need to create a link aggregation between a GWN switch and another server, or even a third-party switch that only has fast Ethernet ports, you must change the port's speed to 100 megabits per second on the GWN switch to match the speed of the other device. When you make changes to the LAG, these configuration changes are automatically applied to the ports in the logical link. When configuring switching protocols and security settings on the GWN switch, these settings must be applied to the link aggregation group interface instead of a physical interface. For instance, when configuring VLANs or spanning tree, the configuration must be applied to the link aggregation group interface instead of applying it to the physical port. Always make sure the same link aggregation type on both ends of the logical link is used. For instance, if you configure one end to use dynamic link aggregation using LACP, the other end must support LACP to establish the logical link. It is very important to create the link aggregation group on both ends before connecting the cables. Using multiple Ethernet cables between two devices before the LAG is created can cause a bridging loop, especially when spanning tree is disabled, and this is something you definitely want to avoid. As I mentioned, load balancing is one of the benefits provided by link aggregation. To ensure the interfaces of the logical link are efficiently utilized, GWN7800 switches use a deterministic mechanism that is based on MAC and IP addresses to load balance traffic across the active member ports of the logical link. GWN7800 switches support two modes for load balancing. So when you select MAC address mode, the traffic is balanced based on the source and destination MAC addresses in the packet. When IP MAC address mode is selected, traffic is balanced based on the source and destination MAC and IP addresses in the packet. This topology shows load balancing using the MAC address mode. Let's focus on the logical link between the two switches. Since the devices trying to access the network storage have unique MAC addresses, load balancing based on a MAC address is more suitable for this case. The switches will balance the traffic across multiple paths based on the MAC addresses of the endpoints. In this topology, we have link aggregation configured between GWN7800 switch and an FTP server on a virtual machine. In this case, it is not suitable to load balance based on the MAC address only because all the traffic coming from the remote workers will carry the MAC address of the router when the traffic reaches the switch. Plus, the server they're trying to access has one MAC address. So in situations like this, it is useful to use IP MAC address load balancing mode because we want the switch to use the unique IP address of the remote workers when deciding how to balance the traffic load on the links. Otherwise, with MAC address mode only in this scenario, the traffic will always be carried over the same physical link because the source and destination MAC addresses are always the same. Some might think that simply adding more links between two switches will increase the bandwidth. This is incorrect because each link on the switch acts independently. So we need to implement a mechanism that would allow the bundled physical links to work as a single logical link. Otherwise, a bridging loop could easily happen, especially when spanning tree is not enabled on the devices. GWN7800 switches offer two methods of creating link aggregation groups: static and dynamic using LACP. And LACP stands for Link Aggregation Control Protocol. Static mode requires manual configuration and management of the logical link and does not detect link failure because no messages are exchanged between the two peers. LACP, on the other hand, uses LACP messages to monitor the status of the active links and is able to detect a link failure. We will talk more about LACP in the next chapter. Let's open the web interface of a GWN switch to demonstrate how to configure link aggregation using static mode. So link aggregation configuration is available under switching, link aggregation. So we already talked about the load balance modes that are supported. There's the MAC address mode and the IP MAC address mode. So we're going to create a link aggregation group. So we're going to choose LAG1 and we will select port 10 and 9. So in this case, we're just going to create a link aggregation of two physical ports, but you can include up to 8 ports in a link aggregation group. We can just call it LAG1. And this is where you select whether you want to use static mode or LACP mode. So first we're going to use static and we're going to create a link aggregation group that includes port 9 and 10. Save. Then we go to port settings. Then we can edit the parameters that apply to this link aggregation group. So the logical link is enabled by default. If you decide to disable it, you just toggle this option. So I'm just going to enable it back. The speed is set to auto, but as I mentioned earlier, if you want to create link aggregation between a GWN switch and a third-party switch or server that is using fast Ethernet ports, you can change that from here so that the media type between the switch and the server or the other third-party switch match. So I'm just going to change it back to auto, then save. So after you create the link aggregation group on this switch, you need to go to the other switch and do the same thing. So I went ahead and created link aggregation group using the static mode on the second switch, and I used ports 7 and 8. So here, as you can see, we have 2 ports that are active in the link aggregation group. If one of these ports gets disconnected from the switch, you will see it available under inactive member. So if we select port 9, you will see that there's traffic going on this port. If we click on port 10, so by checking the incoming packets and the outgoing packets, we can tell that the traffic is being load balanced between the two physical ports. Link Aggregation Control Protocol, or LACP, dynamically monitors the status of the device links and maintains the logical link by exchanging LACPDUs. So if there is a link failure, LACP will detect that and will use the LACPDU message to inform the peer switch. So after you create the LAG on the switch, LACP will maintain the logical link by detecting any link failure or misconfiguration. And this is good because LACP will essentially help reduce the network administration workload. LACP uses system priority to determine which switch will be responsible for choosing which active interfaces to use in a link aggregation group. The switch with the lower value will determine which links are actively participating in a logical link and which are in standby at a given time. If both devices have the same LACP system priority, the one with the lower MAC address will become the decision maker. Port priority is also used to determine which ports are more likely to collect and distribute traffic load. So let's go back to the web interface of the switch and configure a link aggregation group of 2 ports. So earlier we configured a static link aggregation group, which I deleted already. So let's go ahead and use LAG2. So this is where you choose between static and LACP. So earlier we configured static, and static mode is usually implemented when you want to create a link aggregation between 2 devices in a simple network environment where you can easily check the connection between the 2 devices. For example, if something goes wrong, you can check the cables and the port LEDs. You can also choose static mode when the peered server or third-party switch does not support LACP. So let's create a link aggregation group using LACP. And in this case, we can use the same ports again, 9 and 10. Save and apply. So after we create the link aggregation group using the LACP type, we go to LACP settings and we need to change the system priority. For example, if I want to use this one to control or make decisions about the ports that will be actively participating in a link aggregation, then I need to use a lower value. So a lower value has a higher priority. The default value is 32,768, so I'm going to reduce that one to 4,096 because I want this switch to make decisions about which ports are active. So I'm going to save that, and then I will go ahead and select port 9 and 10, edit. So I'm just going to keep the value 1. Next we have the timeout option where we need to choose between short and long. So when you select long, the LACP PDU will be sent every 30 seconds. And the LACP timeout value when no packet is received from the peer device is 90 seconds. That means if this switch sends the LACP messages to the peer device and there is no response after 90 seconds, the switch will determine that the other device is no longer reachable on that port, then it will fail over to the other ports that are still working. If you choose short, the switch will send LACP PDUs every 1 second and the timeout is 3 seconds. So if there is no response from the peer device, it will determine that the port on the peer device is no longer reachable. Then it will fail over to the other ports that are still working. So I'm going to choose short for this example, then save. So I configured the same thing on the second switch. So we have a link aggregation group created using the LACP type. Under LACP settings, I left the system priority as a default because, as I mentioned, I want this one to control the decision about which ports to use. I also changed the timeout to short and the priority is also set to 1. If we decide to change the port priority, so let's say we will set the value 10 on port gigabit 10. So with this change, if you go to the port setting, you will notice that most of the traffic will go through gigabit port 9 and less traffic on port gigabit 10. This concludes today's video guide about LAG on GWN7800 series. Thank you for watching. In part 4, we'll talk about spanning tree protocol. Our engineers at Grandstream Help Desk can assist with any issues that you might run into while using Grandstream solutions. You can submit a ticket by going to helpdesk.grandstream.com.